In today's video, we are going to discuss how we can test whether a solution contains anions, which are negatively charged ions that play crucial roles in various chemical reactions and are commonly found in many substances. Specifically, we will focus on tests for three key types of anions: the carbonate ion, the sulfate ion, and the halide ions, which include chloride, bromide, and iodide. We begin with the test for carbonates. This test is based on a fundamental chemical principle. When carbonates react with acids, they produce a salt, carbon dioxide gas, and water. Although the release of gas alone is not enough to confirm the presence of carbonates, we can utilize a well-known method to test for the gas produced. If the gas released during the reaction is carbon dioxide, it will turn lime water, which is a clear solution of calcium hydroxide, cloudy. This cloudiness is caused by the formation of solid calcium carbonate particles that scatter light, making the solution appear milky. To conduct this test, we simply add a few drops of dilute hydrochloric acid to our test solution and then pass any gas formed through lime water. If the lime water turns cloudy, that provides a clear, positive test result indicating the presence of carbonate ions in the sample. Next, we move on to testing for sulfate ions, which also requires a two-step procedure. The scientific basis here is that barium ions react with sulfate ions to form barium sulfate, an insoluble compound that appears as a white precipitate. However, before we can add barium ions, we first need to eliminate potential interfering substances by adding dilute hydrochloric acid to the sample. This acid helps to remove impurities such as carbonate and sulfite ions, which might also form white precipitates and cause a false positive result. After this preparatory step, we add a solution of barium chloride, which provides the necessary barium ions. If sulfate ions are present, we will observe the formation of a white precipitate of barium sulfate, indicating a positive test result. Lastly, we examine the test for halide ions, which include chloride, bromide, and iodide ions. This test is quite similar to the sulfate test in its structure, but uses different reagents. In the first step, we add dilute nitric acid instead of hydrochloric acid to remove carbonate and sulfite impurities. Then, we introduce silver nitrate solution, which contains silver ions that can react with halide ions to form insoluble silver halides. The specific halide present can be determined by the color of the precipitate formed. If silver nitrate reacts with chloride ions, it forms silver chloride, which appears as a white precipitate. If it reacts with bromide ions, silver bromide forms, creating a cream-colored precipitate. When silver nitrate reacts with iodide ions, the result is silver iodide, which has a distinct yellow color. This entire procedure is often referred to as the silver nitrate test. By carefully observing the color of the resulting precipitate, we can accurately determine which halide ion is present in the sample. These tests for anions are vital components of qualitative analysis in chemistry, helping scientists and technicians to identify unknown substances and ensure the purity and composition of various materials.